For more information, please visit SGMAK Associates website.
Hi, in this module, I'm going to talk about how to use gradient series in cash flow analysis, as well as how you perform a simple break-even analysis. So let's build it around a problem. So you're comparing between whether you want to buy a piece of automation or keep the manual work as you're doing it right now. Here are the data. The annual salary of the worker is $60,000, and typical increase in salary gradient $3,000 every year. The initial cost of automation, you have to pay $75,000 to buy it. The annual operating cost is $12,000 a year, and annual increase, again a gradient series of $1,000 a year. The useful life of the new equipment is 10 years, and the equipment is expected to generate a salvage value of $10,000 at the end of useful life. Firm's borrowing rate is 9%, which is always a parameter that keeps changing. So, we want to find out on a planning period of 10 years whether you should buy the piece of automation or you keep doing the current manual work. This example shows how to use a gradient pattern in cash flow analysis. A gradient pattern may be viewed as an arithmetic progression series where successive terms have constant difference. This increases by a constant amount or decreases by a constant amount. So alternative 1, keep the worker. We solve this problem based on net present value of cost over a planning period of 10 years. So keeping the worker, the base value is $60,000. You're paying end of each year the salary, and gradient is $3,000 per year. Next, so you have a gradient is typically represented by the base value A and the gradient G, and gradient kicks in at the end of second year or second time period. So for a 10-year planning horizon, our net present value is 60,000 times P over A, 9% rate 10 years. That converts the base value to a present, and then the gradient 3,000 times P over G, 9% rate in 10 years, converting the gradient to a present value. And the total amount comes out to be $458,199, close to $500,000. That's the net present value cost for the alternative 1. If you buy the automation, then the initial cost is $75,000. The annual maintenance cost, base value $12,000 and gradient of $1,000, increases by $1,000 every year. And what happens here, the net present value, the cost, all costs together is 170. You got a initial cost of 75,000, then you're converting the base plus gradient to present value. So 75,000 plus 12,000 times P over A, 9% in 10 years, plus $1,000 P over G, 9% in 10 years. And that comes out to be $176,389. So just based on the net present cost, we have ignored the salvage value here, assuming salvage value to be 0 for alternative, for the piece of automation at the end of 10 years. Otherwise, we would have added that as a benefit. So net present cost of alternative 2 is lower than that of alternative 1 in terms of net present cost. So alternative 2 is preferred with the current parameter setting. It has a lower overall cost in terms of present value, so it's preferred. Now, in break-even analysis, what you do, we typically, well, you know, for simple break-even analysis, we typically look at one of the parameters of the problem and we make it a variable, and then we try to find out for what value of the parameter two alternative breaks even. That means they become at par. So as you can see here, alternative 2 is preferred. Now we are saying that alternative 2 becomes unfavorable as the initial cost of the automation goes up, right? Right now you have 75,000. As it keeps going up, at some point in time, uh, you know, it will lose its benefit or advantage, and then alternative 1 will take over. So you want to find the point at which two alternatives break even or become at par. So at par means the net present value of 1 will be net present value of 2, and the variable parameter is the initial cost of this second choice. So the net present value for the alternative 2 becomes the initial cost IC2 unknown plus 101,389, the present value of the base plus the gradient. If you set them equal at break even, that gives us an initial cost of $356,810. So what it implies, current value 75,000, initial cost is very much favorable. As the cost goes up, until it goes up to $356,810, alternative 2 is still preferred. At that value, $356,810, you are indifferent between the two. And as the initial cost for alternative 2 goes past that, you'll preferring alternative 1 because it offers a lower initial cost. So at break even, whatever metric you're using, in this case the net present value, at break even, the net present value or the metric becomes equal for two alternatives, and we typically have one parameter at a time, though it can be expanded to more than one parameter. Then you get a region of parameter values. So with one parameter, we just try to find out at what value of the parameter they break even. So in this case, alternative 1 is preferred if initial cost of alternative 2 exceeds $356,810. Moving on, there's another example here. You got a magazine subscription, whether you want to buy 1 year or 3 year subscription, and it costs you $50 at the beginning of year, and you pay at the beginning of each year $50. Other one, you pay $120 at the beginning of each 3-year period, and you're using 10% minimum rate of return. So we want to find out which one is preferred. This is an example of an initialized cost. So based on that, initial example of capitalized cost. So based on that, the capitalized cost for alternative A is $550, and capitalized cost of alternative B is $482, as the reason given here. So based on that capitalized cost, which is the present value of all future cash flows. So alternative 1 has a present value of $550. Alternative 2 has present value of $482. Is the cost. So plan B has lower initial cost, lower overall cost. So there B is preferred. So 3-year subscription plan is preferred over 1-year yearly subscription plan based on the data given. Just a small example, I have a separate module on effective and annual interest rate. Here's the example statement. You have borrowed $2,400 and have decided to repay it in 24 equal monthly installments of $106.32 each. That's the plan. So what's your monthly interest rate? What's your effective annual interest rate? So monthly interest rate is just using the capital recovery factor. You got A over PI 24. The factor comes out to be 0.0443. So table lookup gives you 0.5% per month. So what's your nominal annual interest rate then? Nominal annual interest will be 12 times 0.5%, 6% APR. And what's the effective annual interest rate? Since you're compounding monthly, is 1 plus 0.05, 1 plus 0.05 divided by 100, 0.005, 1.005 raised to the power 12 minus 1. We are converting nominal to effective with 12 compounding period, and it comes out to be 6.16%. So interest rate is 0.5% per month, nominal annual rate 6% APR, and effective annual interest rate is 6.1%. So this module talks about use of gradient series, simple example of break-even analysis, and a glimpse of computing nominal and effective interest rate. Hope you find this useful.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.